So in the next part, we're going to draw a resulting vector, meaning the end vector. Where do you end up? For example, if I started in the middle of the room and I said, hey, walk to the right 3 steps. 1, 2, 3. And then turn left and walk forward 2 steps. 1, 2. Where I end up compared to where I began, this diagonal, is the resulting vector. Okay? So I'm going to show that visually now on the screen. I'm going to color vector u as a red vector. Here it is, vector u. I'm going to do vector v as a light blue vector. And in the end, my resulting vector I'm going to make purple. So, as I look at part A, and I draw the vector u, which is a red vector, here's what I would see. Here's vector, does it look like it's in the same direction? No, it looks dumb. So I'm just going to redraw it, sorry.
It looks dumb.
So it looks more like, there we go. So this is vector u. Notice it's in the same direction, same length as the one they showed me to begin with. Then vector v starts where I left off with vector u, and then goes in the same direction that they told me to go. So now vector v goes like this. And here's vector v. So vector u ended in the red, and vector v began where it ended. My answer is neither of those two things. My answer is the resulting vector that begins where I started and ends where I ended. So the purple is my answer to the question, what is vector u plus v? The next one says, to you, Tate. Happy birthday. Thank you, Gavin. So my first u looks like this. There's u. Oh wait, I want twice as long as u, so that's another u. And so my answer is 2u.
It's double.
Oh my goodness. And the next one, there's a minus sign. Watch what happens. The u goes like this. There's my u up to the right, about that long. And now I want minus v. Minus v means, give me the v, but go in the opposite direction. So this is minus v. This was u. And then if I connect the beginning to the end, this is my u minus v.
Triangle.
In the purple.
Yeah.
In the last one, we have a v. And v went up like this.
Like this.
And then we wanted to go with a half of a u. Because we couldn't afford the whole thing.
What was that?
This is 0.5 u. And this was v. And my answer is the resulting vector in purple. Questions? In number 6, I'm going to do 2 times v. Here we go. 2 times the v vector. Oh, careful, don't blink. Done. Number 2, w minus v means 1, 2 minus -7 comma 5, which means 1 minus 7, comma 2 minus 5, for a final answer of 8, comma negative 3. Last one, on number 6. I want 2 times v, so that's 2 times negative 7, comma 5, plus the w, which is 1, comma 2. So that would be, if I did an intermediate step, negative 14 plus 1, comma 10 plus 2, for a final result of negative 13, comma 22. Do not forget to write things down in component form.
Why would it be
12?
Yeah.
Whoa, what'd I do?
You said 2.
12
instead of 2.
Whoa!
Oh, I put 12?
Yeah.
My bad,
Wow!
Wow!
Come on, you king.
I'm sorry, I felt a little bit like Gannon today.
Oh, yeah, he really done it.
So this should be a 12?
Yeah.
Okay, sorry, 12, not 22. Thank you. So this next part in our notes is talking about something called a unit vector. It's very important that you know that a unit vector is one with a magnitude, or in other words, length or distance, of 1. The way that you make that happen is basically you take whatever vector you have and you divide it by the magnitude of the vector, and that will turn it into a length of 1. So they give you vector v, divide it by the magnitude, done. Let me show you. In vector v, I see the coordinates negative 2, 4, which means I start at 0, 0, and I go to negative 2, 4. If I want to find the magnitude of v is going to be the square root of, because this is the distance formula, but we have a shortcut. Please stop making noises. Thank you. Negative 2 squared plus 4 squared, we learned this just a little bit ago, which is really then the square root of 4 plus 16, or in other words, the square root of 20. Now we could simplify that, but for right now, I'm going to ignore the simplifying just to show you the technique, and you guys can simplify it later. Now that I have my magnitude, that's the stuff that I was talking about in the yellow highlight up above, I'm now going to take the vector v and divide it by that magnitude. So my vector v was negative 2, comma 4. So my new unit vector, which I'm going to call u, is going to be my negative 2 divided by that square root of 20, comma 4 divided by the square root of 20. And each of these square root of 20s was the magnitude that I just found. So you just look at your vector, whatever it is, and divide by the magnitude. Now if I'm simplifying this, just to show you how this would work out, this magnitude of 20 radical is really the same thing as the square root of 4 times the square root of 5, or in other words, 2 root 5. So everywhere in the yellow highlight, I would replace that with 2 root 5. So as I go along, my next step would be to say that I have negative 2 over 2 root 5, comma 4 over 2 root 5. And I could simplify that a step farther, of course, which means now that I would have negative 1 over the square root of 5, comma 2 over the square root of 5, and oh no, there's a radical on the bottom. So that's when we rationalize the denominator, and my final answer in its simplified format would be negative root 5 over 5, comma 2 root 5 over 5. Some of you may need the intermediate step, some may not. In this next part, we talk about something called standard unit vectors, and they have two parts of this. If I were to look at a coordinate axis system, in which I have the y-axis and the x-axis present. What they mean by these standard unit vectors is that if you look at the I vector, it has a component form of 1, 0, which basically means on my axes, if I look at the number 1 in the x and the y direction, then my standard unit vector I looks like this. The J
I'll take cam
vector,
on one, hold the mail.
the J vector is the vector that goes vertically in the y direction because its component form is 0, 1. And so that's the one that they're talking about here. Now, what they're going to do, and this it seems really confusing when you see these I's and J thing, but watch what happens when we actually do a problem involving I and J. They tell me that we have a vector that has an initial point 4, -7, and terminal point 2, 9. What's the first thing you would probably think about when you saw that as far as writing down a vector? Now we're going to do is we're going to change what they talked about in the green highlight into something in its component form. So in its component form, the thing that I would write down is I would write down the terminal point 2 for the x minus the initial 4, comma, the terminal 9 part minus -7. And so in component form, this vector that started at 4, -7 and went to 2, 9 would be the same as -2, comma, 16. Instead of writing it down that way, what you will do is you will say, hold on for it, that your vector u is equal to -2i plus 16j. Whoa! Whoa! And I was like, whoa! And then it was like, whoa! All right, and number 9. That's it. If you wanted to, this thing that is in standard unit vector form, this was standard unit vector form, can also be written in something called component form. Just a different way to write it down, and I can do this. So if it doesn't tell you which form you have to put it in, either one's fine. In example number 10, we're going to find the angle of the vector. So you need to know that in your component form, when you see it,